Okay, I'm going to work these problems here and show you, the answers to them so that you can check, make sure you're on the right track. Now, I created a couple graphs just on my own paper to show that you can do that. They don't have to be, this one I did by lines to show you that you could go by lines, but sometimes the problems may get big to where this one may not be big enough. I gave you an example of like putting them closer together. So it does not matter as long as you try to keep the spaces the same. Now, obviously, I made a little goof right here, but as best as you can to keep the spaces the same distance apart. Otherwise, that's what's going to throw your graph off. If you've got a space here and then you go way down here to put the next one, that will throw your graph off as far as where it's going. So let's start these, okay? So these you had to graph. So we're going to, this one's already in y equals mx plus b. Remember, that's what we're always trying to go for to start our graph. And this one's already in it. It's going to tell us that we're going to start at -2 here on the y-axis. So our first point goes there. Okay, negative, this is your origin, 0, 0, and you go down 1, 2, so it's -2. And then your slope, okay, so the one slope is going to be 3 over 1, and they're both positive, okay? That's a positive 3, so it's 3 over 1. And remember, our slope is always rise over run, which means from our starting point, we're going to run 1 positive. So we're going to go 1 positive here. And then we're going to rise 3. So 1, 2, 3. You do have to count the axis as one. That's a space of 1. This is a space of 2. This is a space of 3. Okay, so far, we got our line going up, which is what we want. Okay, it's a positive slope, so it's going up. And then the other point I'm going to graph is make both of these negative, and that is also a positive 3. Negative divided by a negative is positive. So this time, go back to your starting point, and you're going to go 1 negative and 3 down. 1, 2, 3. And so there is your line. Okay. Now it keeps going. You could keep going. You don't need to, but 1 over 3 up, 1 over 3 down, it would still follow that line there. Okay. Now this one is not yet in y equals mx plus b. I need to divide by 4. Okay, and so that's going to give me y equals -2x plus 3. Okay, so now we're in y equals mx plus b form. So you had to get rid of the 4 so that you have your y isolated. So we're going to start at 3. So we're going to start the origin 1, 2, 3. We're going to start here on the y-axis at positive 3. That's the y-intercept. And then my slope, okay, first off, it can be -2 over 1. Okay, because that's -2. So let's do that one. That means if I go over 1 positive, okay, then I'm going to go 2 down. So I'm going to go 1 positive, and I'm going to go 1, 2 down. So we're still here, okay, and my slope is going down. Okay, it's a negative slope, so it should go down. But then the flip of this is also this. This is also a -2. 2 divided by -1 is also -2. So let's start back at our starting point and go over 1 negative. So we're going to go in the negative direction, but then we're going to go up 2. Okay, that's going -1 in the run and up 2 on the rise. And so we've got our straight line. And like I said, it's going to be slightly off because I think I put an extra little gap here, but that's it there. Okay. This one also is not in y equals mx plus b, so let's do that. First, we need to move this over. So we're going to move this over and have it cut in line. So this is where we get 2y equals -5x. I had it cut in line, -4. Then we're going to divide by 2. And remember, my slope is okay to stay a fraction. So it's -5 halves x, and I'm just kind of slanting it so you can see it as a fraction. And then this is going to be -2. Don't forget to divide. So this is going to be 4 divided by 2, which is -2 here, -4 divided by 2. So we're going to start here at, now we're in y equals mx plus b. So we're going to start here at -2. And my slope, okay, it's a -5 halves. So that means I can have -5 over 2, which is what that looks like. So we may have to put a couple extra lines here because we're starting at -2, and we're going to run 2, so 1, 2, and we're going to go down 5. So 1, 2, 3, 4, 5. They'd be like down here. Okay, so we'll add a couple more lines to our, okay. So here's my next point. So we got a really steep slope here, but it does go down, which a negative slope we want to go down. And then the other way is to have a -5/2 is to have it like this. Okay, this is also -5/2. So that means I'm going to run 2. I'm going to go back to my starting point. This one is another one that I've kind of gapped that a little bit further. But I'm going to go 2 negatives, so let's go about right there actually. And then go up 5. So 1, 2, 3, 4, 5. And there's my steep line here. Okay. Last one on the graphing. Okay, we need to move the 3x and have it cut in line. Now don't forget that's a -y though, equals 3x minus 3, and that's a positive 3x that cut in line. And then so we're going to move this negative over here. Now you're dividing it by -1. That's what you're doing, okay, to get rid of the negative. So don't forget to change the sign on both of these. This is now going to become a -3x, and this is now going to become a positive 3, okay? So don't just change the sign of the 3x, you got to also change the sign of the 3. So that means we're actually going to start at positive 3. Okay, my slope is negative, so my line should go down, but it's -3, so that's either -3 over 1, which means we go 1 over positive, 3 down, 1, 2, 3. Okay. And it just happens, the next point happens to be the x-intercept where it crosses the x-axis. And we'll look at that on the next page as far as the other problems. But we can also have this be 3 over -1, which we're going to need another line up here. So that means we're going to go 1 over negative and 3 up. 1, 2, 3. So here's my slope. All right, so check your answers. Obviously, the more challenging, if it's already in y equals mx plus b, you know, it's easier because you could ready to graph. But then these, that's why I put these on here. You have to put them in that form first, and there's, you know, obviously a chance for mistakes. You know, and I try. The thing is, just so you know, when I'm grading something like this on a test or an assessment, you know, I'm checking for several things. So let's say you did this wrong, like just maybe you forgot the negative and forgot to do that. You know, okay, that's a point. That's what I'm checking for first. But then if you do your graph right off your wrong, I'm going to take that into consideration. I mean, obviously you knew how to graph, you just started out wrong. So kind of keep that, you know, don't just give up. Make sure you're following the problem all the way through. Now, obviously, to get all of them right, you're going to want to get this to right to begin with and then go from there, okay? Now, the next problems I had you do was to find the y-intercept and the x-intercept. So let's do that. No more graphing on these. We're just going to find the y-intercept and the x-intercept. So the y-intercept on this one is, it's already in y equals mx plus b, so it is -5. We don't have to do any map. So I'm going to put y-intercept equals -5. The x-intercept, we're going to have to do a little math. We're going to replace the y with 0. Okay, so we're going to replace, I'm substituting that in, and now I'm going to solve for x. Okay, so we're going to add 5. Okay, and we're going to divide by 5. Okay. So 1 is x, okay? Now, if you're one that, like we talked, so the x-intercept, let me finish that off, is going to be 1. Now, this, remember, is going to be 0, -5, okay? Because when x is 0, y is -5. This is going to be 1. When y is 0, x is 1. So that's going to be your y-intercept and x-intercept, okay? And that's a 0 here. Now, if you're one, like on this part right here, if you need it, you know, I know we talked about always having the variable on the left side. All you need to do to start that problem is just switch places, okay? So I put this on the left side, I put this on the right side, and you still can solve it the same way. You add 5, and you get 5, and then you divide by 5, and you get 1. Okay, so if you're one that needs it on the left side, you can still do that. Just switch places to start out with. Okay, all right, let's do this one. Now this one, we can't do the y-intercept yet until we get rid of this 2. So we're going to get 2x plus 4. So the y-intercept is actually 4, and that's when x is 0. And see, if you think about it, you plug in 0, you get 2 times 0, which is 0. 0 plus 4 is 4. So when x is 0, then the y is 4. So that's your y-intercept. Okay, but what's nice is when it's in y equals mx plus b form, all you got to do is just identify it. You don't have to plug in 0 for x. You just identify it. It's right there. It's 4. Now, to find the x, I'm going to put in 0 for y and solve for x. So I'm going to move the 4 over. Negative 4 equals 2x. I'm going to divide by 2. And negative 2 equals x. So that means my x-intercept is negative 2, 0. When y is 0, x is negative 2. Okay. Let's do this one. This one's almost so small it's kind of hard, but you need to move the x over here. It cuts in line. And so now you know your y-intercept is 8. Okay. And now I'm going to solve for x. So I'm going to plug in 0 for y. And I'm going to solve for x. So I'm going to move the 8 over. And now I'm going to put the negative, change places. Okay, so I dropped the negative here, so I got to do the same thing over here. So x is 8. So my x-intercept is 8, 0. When y is 0, x is 8. Last one, we need to move the 8x. Oops. Okay, we're still not done. We need to divide by 2. Get rid of the 2. So now we've got negative 4x plus 4. 8 divided by 2, 4. So my y-intercept is 4. Okay. And to solve for my x-intercept, let's put in 0 for y. And let's solve for x. Put the negative 4 over here. Okay, that was a negative 4x. I'm going to divide by negative 4. And negative divided by negative is positive. So my x is 1 when my y is 0. All right. I know, it's easier when you see them, and as you're learning them, it can get frustrating, like, oh, what was all the rules? But, keep practicing, go back through. If you missed a lot of these, start over. You're not going to memorize these, so it's good to just start over, see if you come out to the right answers this time after seeing it, okay? All right. Now, what I want to show you with this a little bit is I just want to do a couple problems just to expose you. I'm not going to necessarily quiz you on this. I just want you to see a little bit further. Obviously, this term being a little bit shorter and us being pressed for time anyway, there was some things I didn't quite get into, but I do want to take this out of the realm of abstract and just doing math problems with letters and explain that this can be used and it is used in everyday math. And an example of that would be like, okay, so we're talking about input output, and let's say you're trying to do your cell phone bill or DirecTV or Dish Network or something like that. We all know that a cell phone bill or a TV bill or something like that, they're going to charge you like an installation fee or a startup. That is going to be the same for like every customer, or even if they waive it or something like that, there's going to be, that's a constant as far as you don't pay that monthly, but you pay it to start out with. Well, if you think about that as being on a graph, okay, so That's what we're talking about when we do the y-intercept. Like, where are you starting at? You know, you're going to be changing over time, but where do you start that starting point at? Well, on a cell phone bill, let's say, and I'm going to put this as a y equals mx plus b kind of thing. So that would go here, like, hey, we're going to charge you $50 to set up your phone. Okay. Well, that means if I'm trying to figure out what my bill is after a certain amount of time, I know that it's going to cost me $50, and then this is going to be what changes. The slope is what changes. So this is going to be like the monthly bill. Okay. Now, as far as this form, it doesn't always have to be like monthly. It doesn't always have to be like even a cell phone bill or something like that. It's just we're going to make it what we need it to be, and then we can use this to figure out how much it's going to cost us over time. So let's say what we're trying to find out is how much it's going to cost me. And let's say I'm doing a monthly bill. Let's say I want to find out after 8 months. So 8 months at whatever cost. Maybe they're going to charge me 20 a month. That'd be nice, right? Okay. Well, to explain this is to show you, okay, 20 a month is going to be 20 a month. But let's say, same thing, 20 a month, and they charge me $50. But let's say I'm going to do it for 10 months. Okay, this time. This changed this time. The slope changed, you know, as far as what I'm inputting in. Okay, so in that case, then here's going to be $160 that I paid in monthly fees because I was paying 20 a month for 8 months, but I'm still going to pay that 50 starting point. So that means if I go 8 months, I pay 210. But in this scenario, I went 10 months, so it's going to be 200 because 10 times 20. I'm going to be paying 250. Okay? And I know you don't always, you know, like a lot of people figure these things out just on their own thing. But in business and as you go on, some of these get really hard. It may be you need that formula, you need that plug-in every time so that you're not always going, well, how many more months did I do? And it's 20 more. So if I did 2 more months at $20, it's $40. That's the $40 difference. This plugs it right in as you go along. Okay? And so you're able to figure out, you know, what's it going to cost you over 10 months or 30 months or, you know, whatever amount of time that you're going to change, your X input's going to change each time. You can set this up and know, you know, what that's going to cost. Now, someone else may come along and be like, hey, I had to pay, I didn't have to pay a startup fee. Okay, well, let's say I only had to pay $10. We'll still keep a startup fee. So, you know, hey, look at that, I saved money, but maybe they have to pay $30 a month. Okay, yeah, they got waived a fee, but let's say they go, let's say they go 8 months, okay, and compare it to this. Okay, so they paid $240 a month. They paid 10 to start up. Well, look at that. They actually paid more over time because they were paying more per month. And yes, this is lower, but it shows that, you know, they were paying more per month. Okay, so that's an example of where you can figure those things out. Another way you could set this up as far as just realizing inputs and outputs is you could set that side by side and say, well, when, you know, let's say you join a gym, okay, and let's say someone only paid $10 to join that gym, but they pay $20 per month, and we'll even use M for month, okay, and then someone over here, they pay, let's say they pay $5 to join, $5 to join, and then they only have to pay 10 a month though. Okay, and you're going to be like, well, when will those start to, you know, how many months will that start to be the same and that kind of thing? Well, you could just solve. You could move your 10 over here or something like that, and you know it's actually in no time at all you're going to save because it's going to be a negative number. But you know that gives you an example of how quickly, you know, just by paying less a month can save you time, save you money, that kind of thing. You know, to expand that out, to give you a bigger example, let's make it bigger so we don't come out negative. But let's say someone paid $100 to join and pays 10 a month. and someone else maybe only paid 50 to join, but they only have to pay 5 a month. Okay, so let's look at that. Actually, let's switch these. Sorry, it's always fun doing algebra problems off the cuff. But let's say sorry, I should have switched those. So they had to pay less to join, but they got to pay more a month. And this person had to pay more to join, but pays less a month. So at what point do they end up paying the same thing, or what point does this person maybe start coming out ahead? Because right when they walk in the door, this person pays $100 and this person only paid 50. And so this person saved 50 bucks. But over time, that's not going to be true anymore. So to find that out, we can move this over here. Okay. And over here, we have 100. And then we can move this over here. Okay, and then divide by 5. And so in 10 months, they're going to be exactly the same. So if I plug in 10, that's when they're exactly the same. So in 10 months, this person, because they were saving $5 a month, made that $50 back that they paid more at the beginning. So everything after the 10 month, this person is saving money. Okay, now if for the first 10 months, this person saved money by paying $50 less. But then after 10 months, then this person starts saving money. And so it just shows you that you can use these equations. And like I said, I'm not going to be testing on this. It was too short a time to try to cram it in, but I did want to show you that these have actual put in real world scenarios have value, and that you can use these. Like the graph one, this is something that happens every day. You call a plumber out, they're going to charge you to start, and then so much per hour. And so you could do something like this per hour. There's so many things that charge you a starting fee and then charge you so much per whatever. And so it gives you an idea how to set these up and solve. So anyway, wanted to pass that on. And so be watching the announcements as we're wrapping up here so that you kind of know the rest of the class, what's expected. And so anyway, hope you guys have a good weekend.